Okay, so this video is 1.2 inverses of linear functions. And we have two objectives: to solve for the inverse of a linear function and to graph the inverse of a linear function. Now, the inverse function is really a function that undoes another function, which we can see by the definition here. And what we mean by that is if I have a regular function, which we'll call f of x, and I have an inverse function, which we can call f of negative 1 of x, which we just normally refer to as the inverse f of x, which is what that negative 1 is for, okay? And this original function is going to take an x value in and a y value out, which let's give that an actual value. So let's call that into out negative 3. Then the inverse function takes a y in and gives us an x out. So if I flip those other points, it should have taken in a negative 3 and given us a 2. It does the exact opposite. It undoes the action of the original function. So if the original function takes us from 2 to negative 3, the inverse takes us from negative 3 to 2. Now when you look at this graphed function, if we have a function graphed, we can easily find what the inverse function is by just reversing those points. So if I have a point here, which is 1, 7, let's go here, negative 2, 1. Let's keep going, negative 5, negative 5, and then finally all the way down here, which is negative 7, negative 9, okay? Let's flip these 4 points to find the inverse function. So the first one, negative 7, negative 9, becomes the opposite, negative 9, negative 7, which puts us here, okay? We have negative 5 next. We flip those, we get the same exact thing here. Let me label those, negative 9, negative 7, negative 5, negative 5. The next point, negative 2, 1, we flip those, we get 1, negative 2. Okay, and then 1, 7 becomes 7, 1. Okay, now I draw my straight line, as straight as can be, and there it is. And you can kind of start to see this pattern, right? It almost looks like there's this invisible line cutting through the center here, all right? And we normally call that the line of reflection, and this point should be the same distance from that line of reflection that this one is. Okay, and we won't be testing on the line of reflection, but it's good to know to see that pattern. If it doesn't look like they're being mirrored over a line like that, they're not inverse functions. Now, the first thing nope, that's a pause and try, okay? I want you guys now to find the inverse function given this graph function here. All right, the next thing we want to be able to do is find and graph the inverse function when we're only given the function, not something that's graphed. Now, yes, you could go ahead and graph this, but that only gives us the view of what's here in this coordinate plane, and then flip those points, right, to get the inverse function. But we want to algebraically find what the inverse function is, okay? Now, if you remember back to the notation, we flip the x and y values. We're going to use that here to algebraically find what the inverse function is. So I'm going to take g of x, I'm going to make it back to a y. If you remember, function notation is a placeholder for y. It just helps us keep track of the x values we plugged in. And I'm going to go ahead and flip that input and output. So I'm going to go x equals 2y plus 4. Now, once I flip these, I will resolve for y because we want that to be our input, right? We want that, our notation, to cover that. So I'm going to solve for y. So I subtract 4 to both sides. I'm left with x minus 4 equals 2y. And then I divide both sides by 2. Now, I always write my y on the left side, so I'm going to go ahead and flip that right over here. That should be an arrow. So y, because 2 over 2 cancels, equals, and so x over 2 just stays as x over 2. And then negative 4 over 2 becomes minus 2. Now, it looks like we're done, but the very last thing we want to do is put this in the inverse function notation. So we know that this is the inverse of g of x. So I'm going to take that y again now and make it g of negative 1 of x, or the inverse g of x equals x over 2 minus 2. And this is going to be our inverse function. Now that I have both of them, I can easily graph it, right? These are both in slope-intercept form. So find the slope, find the y-intercept. So the first one has a slope of 2 and a y-intercept of 4. So I put that on the graph and I go up 2 over 1, 2 over 1. And I like to do it all the way through because I really feel like when you estimate the rest of your line, it tends to curve. And then we don't really know where these points are meeting, or these functions are meeting. So that's g of x. And then the other one is x over 2, so that's a slope of 1 over 2, and a y-intercept of negative 2. So negative 2, and then up 1 over 2, up 1 over 2, up 1 over 2, all the way through. And then I'm going to do it in the reverse. I can see where they meet, and I keep going. Okay, let me try that again. And it's pretty close. There's my line. And you can kind of see it, right? You can kind of see that there's that line of reflection. And if I start checking points, let's say I look at this point. That's 1 comma, that's 2 comma negative 1. Then that means the other function should have a negative 1 comma 2, which we see right there, negative 1 comma 2. So these, and I could check more points, but these are inverse functions. Now the other one, with d of w equals 3 over 2w minus 3, we run into some more difficult things in finding that inverse function, which is why I wanted to do this example. So I'm going to run through these steps again. First step, take my function notation, make it a y. So y equals 3 over 2w minus 3. Let me zoom in here. Now after I've done that, I need to, well, I know I used y and there's a w there. That's all fine, right? X, y, we can really use whatever we want. But once I do this, I need to flip my inputs and outputs. So this becomes w equals 3 over 2 y minus 3. And then I resolve for y. So I add 3 to both sides. I'm left with w plus 3 equals 3 over 2 y. And when I get to this point, I have a fraction, right? And we know that this fraction is being multiplied with y, so we have to divide the fraction to both sides. But if you remember, whenever you divide a fraction, you have to flip it, right? So if I write this, that looks super weird, right? And so we're going to change flip. So we keep the 3 over 2, we change the division to multiplication, and we flip the 3 over 2. So let me change that. And so this becomes multiply by 2 over 3. And I do that to both sides. Long story short, when you have a fraction you divide it to both sides and you're solving algebraically, just flip and multiply it to both sides. And you'll see that it cancels out because I end up with a 3 over 3, which is a 1. I end up with a 2 over 2, which is a 1. So I'm just left with y on the right. And then I have a distributive property on the left, right? So I distribute this in, and I get 2 over 3w plus 2 over 3 times 3, which again, you can see I get this as a 3 over 1, which puts another 3 over 3. So I'm left with a 2 over 1, or just 2, equals y. Now I'm going to convert that back. I'm going to move my y to the left side. So y equals 2 over 3w plus 2. And I'm going to put this in terms of the inverse function notation. So d of negative 1 of w equals 2 over 3w plus 2 at the end there. Okay. And that would be that inverse function notation. And make sure you go all the way. Don't just leave it at y, because then I don't really know that's the inverse function and which function it's the inverse of. Now again, both of these are in slope-intercept form, so I'm going to graph them. D of w has a slope of 3 over 2 and a y-intercept of negative 3. So I'm going to plot that negative 3, and I'm going to go up 3, over 2, up 3, over 2, up 3, over 2, up 3, over 2, do it in the inverse direction so that I can get a line all the way through. Okay, so that is d of w. And then I'm going to do the other one, right? So our inverse function has a y-intercept of 2 and a slope of 2 over 3. Oops, that's not right. 2 over 3, 2 over 3. You should see them meet and cross. I'm going to go the other direction to make sure that it's all the way through. I always recommend labeling these so we know which function that you're talking about. And again, we could check those points and we can see that they are just simply flipped, and that kind of helps us verify to ourselves that we did the right thing. Now, I've given you guys 2 more. They're pretty similar. I want you guys to give it a pause and try these on your own.